min and study the sign. Okay. So I have the function, this is it. So h prime of x is 3x squared minus 27. This is the first derivative. Now, in order to find critical numbers, I know that critical numbers come from two possible sources. Can anyone refresh our memory on which sources?
Zero or undefined.
Excellent. Obviously, this is not possible for this situation because this is a polynomial function. But this is possible. 3x squared minus 27 equals 0. Of course, I will divide both sides by 3 to make my life easier. And I know that this has two solutions. I don't really need to do anything else at this stage. I will just write the solutions. What are they?
Really, minus 3 and minus plus 3.
Awesome.
But I have a question before that.
Yes, please.
We have on homework too. Undefined, we don't need that. What that means?
Excellent.
I'm confused on that.
Yes,
Yeah.
yes.
Because of the polynomial, we don't need it. This means
Exactly. Exactly, because it's a polynomial, and a polynomial will never have a corner or a cusp. Excellent, yes. But I have to look, and I have to remind you at all times that critical numbers can come from two sources, and we have to verify both. But if you can say, you can say I'm sophisticated now, I understand this, and I don't have to write it because it's a polynomial, just write polynomial and I'm fine. But I always have to check both sources.
I understand that.
Very good. Perfect.
I wasn't give attention on.
That's okay. Anytime. Okay. So now we have -3 right here, right now, right here, right now. -3, 0, and 3, 0. Nothing undefined. I cannot put a bar like I just did on that problem. And now I have to study the sign. Not before I plug in the function -3 and get this number, and I plug in the function +3 and get this number. I cannot have empty spots here because I have to graph this function eventually. So I have to plug in -3 in the function and 3 in the function and see what we get. So I'm going to share my screen, and we put in the function. Okay. And the function was x cubed minus 27x. And all I want to do is plug in -3 and then 3. So when I plug in -3, I get 54. I write the number here, 54. And when I plug in 3, I get -54. Awesome. Now I have to study the sign of the derivative. Good. Here's the derivative. When I plug in 0, what sign do I get when I plug in 0? Right here between these two solutions. What sign do I have here when I plug in 0?
Negative.
Sure.
So negative.
Good. So now let's plug in 100. 3 times 1,000. No, 10,000. Positive, of course. Good. At this point, I stop and I said, this is my moment of truth. If these two rows do not work correctly together, or they are not in sync, I'll say stop, I have an error. So now let's see. The function goes from negative infinity to 0. What does the function do when it goes from negative infinity to 0?
Increases.
Is that supported by the sign of the first derivative?
Yes.
Awesome. From 0 to 54, what does the function do?
Increase.
Is that supported by the sign of the first derivative?
Yes.
From 54 to 0, what does the function do?
Decrease.
Is that supported by the sign of the derivative?
Yes.
Perfect. From 0 to negative 54, what does the function do?
Decrease.
Is that supported by the sign of the first derivative?
Yes.
Excellent. Finally, from negative 54 to 0, you got the pattern. Now, I finished the increasing, decreasing. Now I'm able to finalize max min. Okay. So, where the first derivative is 0 or undefined, I need to identify what point is negative 354 and what type of point is 3 comma negative 54. Anyone?
Could
The
you
first
repeat that?
one, max.
Yes, because it's positive and then negative. So this one has to be a local or relative, whatever you like, max. What about 3 comma negative 54? Look at the sign of the first derivative and say, I know 3 comma negative 54 is,
Minimum.
yes, relative minimum. We're done with the first derivative. Done, done. I don't need anything else. It cannot give me anything else. Awesome, awesome. Now I'm going to study the second derivative. So then h double prime of x is 9x. Again, h double prime, can it be 0 or can it be undefined? Of course, it's a polynomial, as Tess stressed out. She said, well, why are you doing this? It's polynomial. She's right. He's absolutely correct. Good. But can it be 0? Yes. 9x can be 0 for which x?
0.
Excellent. So then I go back here. Now I need to study the sign of the second derivative. And then I'll explain how this works in a minute. Okay? So 9x. Can you pick a number to the left of 0 and tell me the sign of 9x?
Negative.
And pick a number and tell me the sign of 9x to the right-hand side of 0.
Positive.
Perfect. Before we finalize the table and start the graph, I just need to mention something very important. When the second derivative is positive, the function is concave upward. When the second derivative is negative, the function is concave downward. So then, in order to finalize my table and start the graph, I have to put these symbols where they belong. Second derivative negative. The graph on this piece will have to look like this. On this piece, between 0 and infinity, the concavity will be this, because the second derivative is positive. Final question. What type of point is 0 comma 0?
The origin.
Careful. Yes. The second derivative changes sign. So this is what's happening. Here, the second derivative is negative, and here the second derivative is positive. That's why this is an inflection point. Here the second derivative is positive, here the second derivative is negative. That's why this is an inflection point. So the inflection point exists if the second derivative is 0 or undefined, and it changes sign, exactly like with the first derivative. So 0, 0 is an IP, an inflection point. We filled in everything in the table. We have the limits, we have the x and y intercepts, we have the max min, and we have the inflection point, we have the increasing, decreasing, we have the concavity. Everything is in the table. I don't care to look anywhere else. All this is gibberish. It's not useful to me at all unless it's in the table. And the table will help us graph the function. Okay, ready? That's all I need. Nothing else is important, just the table. So let's do this together. Once you understand this, you will have zero difficulties, I think. Okay, I first have to plot the points. What points? 0, 0, negative 354. I'm going to say 10, 20, 30, 40, 50, 54. Negative 5.2, so 3, 4, 5.2. Negative 5.2, 0. Negative 354, 0, 0. And the same on the other side. It's symmetric with respect to the origin. 1, 2, 3, 10, 20, 30, 40, 50, 54, and 5.2. So that's my first step. I position all ordered pairs I have. I have 3 x-intercepts. I have a relative max, and I have a relative min. And now I follow the table. Ready? Okay. Coming from negative infinity, increasing, opening down to the x-intercept. From negative infinity to the x-intercept, increasing, opening down. Still increasing to the relative max. But now it starts decreasing. Here's the arrow, decreasing to the origin, still opening down. Where it has an inflection point. At the inflection point, it will change concavity. It will decrease to the relative minimum, opening up. It gets to the relative minimum. It's increasing now, crossing the x-axis and going to infinity. And this is the graph of h of x equals x cubed minus 27x. You can check with the calculator anything you want. It doesn't matter. The calculator will not give you more. This is absolute it. So if you want, we can do that. So in y equals, I already have the function in. I already know that I have to change the viewing window because I will not see what I'm looking for because I already did my work, hard work. Okay, so I go to the viewing window. I want from, for the x, -7 to 7 is good enough. with a scale of 1, but the y minimum has to pass negative 54. So I'm going to say negative 60 to positive 60, and I want the scale of 10, so I don't see all those tick marks so close to each other. Now I can graph, because I know where and how it looks like. Here it is. So this is the negative 5.2, this is the 5.2. This is the inflection point, and here's the maximum. You can always determine the maximum to check if you want with second and calc. And I want to check the maximum. So it's 4. It will ask me a left bound. Okay, I'm going to say negative 5. And I want the right, it's asking me the right bound. And now when I click enter, it better give me negative 3. X equals negative 3 and y equals 54. Okay, this is the error of the calculator. Okay, it should have been negative 3. Because if you plug in the function negative 3, you know we get 54. And y is 54. So careful, even the calculator makes errors. Or has some tolerance. Okay, you can determine the other one, but of course you will determine it with a minimum. So I want a minimum this time with a 3. I want the left bound to be 0. I want the right bound to be positive 6. And no, I don't want to guess. Just give me that your 2.999 whatever, which we know it's not correct. Because if we plug in 3 in the function, we get negative 54, as we know. Here's the graph. Here's the table. There is no rounding error here. So careful. It's good that we did this so we can look at what's happening here. So the idea is to build the table. Once I build the table, I have all the information step by step, what I need to do, how I graph. And that's how I graph. Nothing else matters. This is gibberish. It's all over the place. If I don't summarize it, I will never know what to graph and how to graph it. But once I have this table filled in completely with concavity, you don't have to write separate. Oh, the function is concave downward between negative infinity. I see it here in the table. Oh, the function is concave upward between 0. No, there is no need. You already put the symbol in there. And I know that you know what you're doing. So everything in the table is good enough. Okay, any questions?